Hello friends, welcome to part 2 of Mathematical Physics Paper Solution C1 paper 2021 held in January February 2022. So this is for BSc first SEM set by Dibrugarh University for Physics Honors. So today we're gonna complete this paper. Doesn't matter how long this video gonna be, because from tomorrow your exam gonna be start, right? BSc first semester exam going to be start from tomorrow, so that's why I wish you all the best. So before we start, please subscribe the channel if you are new to my channel. Also share the video with your friends and hit the thumbs up button as well as bell icon, so that you get notified when new video will be uploaded. And please help me to grow my channel so that I can create new contents for you. And one important thing that go and check the community post. I have posted a poll there, so you may select a course that you want me to create for you for BSc your next semester. So from January, from next year January, that means from 2023, from the month of January, I'm gonna upload the videos on that particular course. Okay, which one will be selected by maximum students. So now let's start. So in part 1 we have solved up to question number 2. Now we are going to start from question number 3. So here you see this is the 3a. What do you mean by linearly dependent and linearly independent solutions? So here you see, suppose we have two solutions, y1 which is a function of x, y2 function of x, solutions of a homogeneous differential equation. Then y1 and y2 are said to be linearly dependent if and only if the Roskin is identically 0. So otherwise they are linearly independent, right? So here you see, we have already discussed about this Roskin method in the first part, so I hope you have understood this statement. So now let's go to the next part of this question. So here you see, these are the two functions. We need to check they are linearly dependent or independent. So these are the solutions of this equation, this differential equation. So here, so let me first find the y1 dash. This is y1 dash, then this is y2 dash. Then let's find the Roskin. Here is the denominator, so its value, you know how to evaluate a denominator. Just if you apply this method, then this value of this Roskin of these functions, we have got -3, which is not equal to 0. So that means they are linearly independent. They are not linearly dependent, they are independent, right? So if we had got 0, then it should be these two functions should be linearly dependent, right? So hope you have understood this. Now let's go to next question. So here you can see this is the next question. We need to prove this one. So first let me simplify this given equation, so we can make z equal to this, right? Then let us differentiate z partially with respect to x. So we have got this result, and in order to differentiate this terms, I have applied this rule u by v. Derivative of u by v is given by v derivative of u minus u derivative of v by v square. I have applied that rule, so hope you can understand that. So now you see, then similarly let us find del z by del y. So we have got similarly we have got this result, del z by del y, right? So we have got del z by del x and del z by del y. So if you subtract these two, you will get this term, del z by del x minus del z by del y, because on the left hand side you see we have del z by del x minus del z by del y whole square. That's why we have evaluated this del z by del x minus del z by del y. So the next page, let's go to the next slide. So here you can see, so it's it will be equal to this. So here we have taken LCM, then after simplification we have got this value, right? Now take the left hand side. So what was the left hand side? This is the left hand side. here you can see this is the left hand side of this equation that we are to prove, the relation that we need to prove. So here we have taken the left hand side, this is the left hand side, then we have put the value of this del z by del x, which is already evaluated, and del minus del z by del y, right? So this is our left hand side. On squaring we have got this, right? So now you see, now take the right hand side, this is the left hand side. Now let us find the right hand side. Okay, this is the right hand side, and if you put the values of del z by del x and del z by del y, and if you simplify, then you're gonna get this result again, which is same as the left hand side. So that's how left hand side and right hand side becomes equal. So the given relation is proved. So hope you have understood. Then if you have understood, just pause the video and note it down. Okay, so now let's move on to next question. So here is the next question. Here we have a differential equation we need to solve. So once you have solved this equation, then with the help of its solution, we need to find the solution of this equation given below here. So let me first solve this equation. So here this equation can be written in this form, so where f of d is this, right? So our auxiliary equation f of m is equal to 0. So f of m will be, so if you replace the d by m, then you will get this equation, and if you solve it, then you will get m1. You're gonna get two roots here, 1 and 2. So I have taken first one as m1 and next one as m2. So here we have got cf. So c1 e to the power mx, when roots are real and unequal, then the cf is given by c1 e to the power mx plus c2 e to the power m2x. So here m1 and m2 are 1 and 2. If you put those values here, then cf gonna be this is your cf. So now you see, when on the right hand side of this differential equation is 0, it is not a function of x, it's 0. So then your particular integral will be 0, pi will be 0. So that's why the cf will be the only solution, right? So solution of this equation will be equal to its cf. So this is the solution. Now if you see the next equation, so this is the solution of equation number 1. So I have taken the first equation as equation number 1, and this is the solution of equation number 1, right? So if you want to find the solution of equation number 2, let me take the second equation as equation number 2, the next equation given in the equation number 1. So if you see the left hand side of both equations, left hand sides of these two equations are same, but right hand side is different. Right hand side of these two equations are different. So in the first one there was 0, in the next one we have e to the power thrice x. So e to the power thrice x. If you compare with this form of differential equation, so we can find a particular integral, right? So pi, so that's going to be given by 1 by f of d e to the power ax. So here if you compare this e to the power ax with e to the power 3x, then a value of a will be 3, right? So if you put this here, a is equal to 3, then you're going to get pi is equal to this one. So this is your pi, right? So complete solution will be given by y is equal to cf plus pi, and if you add them, if you put the values of cf and pi, you will get this get this solution. So this is the solution of equation number 2. This is the solution of equation number 2. So hope you have understood this. Now let's move on to next question. So here you see, so what is directional derivative? Find the directional derivative of this function, right, in the direction of this this vector 2I cap plus j cap minus k cap. So directional derivative, this is the definition, right? So you can write this way: the directional derivative is the rate at which any function changes at any particular point in a fixed direction. Suppose we have a scalar function phi, which is a function of x, y, and z, be a scalar point function, then the directional derivative along the vector d, this is another vector d, is the component of this grade phi in the direction of vector d, which is given by this. So here d cap represents the unit vector of d vector, which is equal to d vector divided by magnitude of d vector, right? So hope you're gonna get this down. let's solve the next part of this question. This is the next part. Here you can see, let me clean it. So this is the next part of this question. So here you see, so this is the scalar function phi given. At this point we are to find the directional derivative along this vector. So this is the d vector 2i cap. So here you see, I have taken this vector 2i cap plus j cap minus k cap as vector d, right? Vector d. So in this direction we need to find a vector d. So in order to find the d cap, just find the magnitude of d vector. So that is root 6, and that's how we have got we know the unit vector is given. Unit vector of a given vector is the vector divided by its magnitude gives the unit vector, right? And grade phi, if you find a grade phi, so you know how to find grade phi, grade of a function. So hope you should know this. So if you don't know, just watch the videos which are in vector calculus. Go to the playlist, you may check there. Okay, so that is how we have find the first I have found a grade phi. Then for this point, if you put x is equal to 1, y is equal to 1, z is equal to -1, then you will get this grade phi is equal to this one. Now grade phi dot d cap, that means unit vector of d, then you will get the directional derivative, which is equal to 8 by root 6. So pause the video and note it down. So now let's move on to the next question. So here you see state Bayes theorem of probability. So this is the theorem. Here you see, so we have b1 b2 b3, suppose n number of events, and p of bi, any particular event, probability of a particular event bi is not equal to 0 for I is equal to 1 2 3 dot 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 n of a random experiment. Then for any arbitrary event a of the sample space of the above experiment with p of a greater than 0, we have this. So that's going to be given by this formula. So here you see, this is the Bayes theorem, this is the statement. So it's a little bit complicated, so I'm not going to explain today because we have to complete the paper. So just remember it. Okay, so now let's solve the next part of this question, the numerical part, right? So here you see, so this is the question. 6 cards are drawn from a pack of 52 cards. The probability of that 3 will be red, 3 will be black. So we have total 52 cards in a pack, and out of 52, 26 are red, 26 are black, right? So out of 52 we must select 6 cards. So there will be 5 C4 combination, 52 C6. So 6 cards are selected from 52 cards. So this is the total number of ways, total number of cases, or total number of ways we can select 6 cards from 52 cards. And here the favorable ways or favorable cases are given above. Here you can see these are the favorable cases. So there are 26 red cards and 26 black cards, and from 26 red we can choose 3 red cards and 3 black cards, right? And the number of ways we can select 3 red cards from 26 is given by 26 C3, and for the black card also 26 C3, because we are going to select 3 black cards from 26 black cards, right? So hope you have understood this. So if you evaluate this, then you will get the answer. So I don't want to waste time evaluating this, so do by yourself. You know the formula of combination, that is n CR, that is factorial n divided by factorial r into n minus factorial r. So use that formula to evaluate these combinations. So now our next question is Green's theorem. So here is the statement of the Green's theorem. So this is the formula, and we next part of this equation here is starting from Green's theorem, so that area bounded by any closed curve is given by this expression. So first let me explain the Green's theorem. Here you say, suppose we have a region R, closed region in an xy plane bounded by a simple closed curve C. Suppose M and R are the continuous functions of x and y, right? Then having continuous derivatives in R, So this m and r related by this integration. So this is the, this you see, this represents integration. This symbol represents integration over integration over a closed curve, right? Integration over a closed curve. So here you see, so if you want to prove this, the area bounded by any closed curve is given by this expression, just put capital M is equal to -1 and n is equal to x in Green's theorem. Then you will get this on the left hand side, and using the Green's theorem the right hand side should be this, and if you differentiate this x partially it will give you 1, and if you differentiate this y then it will give you 1 plus 1, we have got 2 here, and integration, surface integral dx dy, right? Dx dy is nothing but area bounded by the closed curve, so that is twice a. So we have got twice a is equal to so that means we have got twice a is equal to integral over closed curve x dy minus y dx, right? So therefore a will be equal to half of this, that is given by this expression, right? So a will be equal to, so similarly a will be equal to half of integration over closed curve c x dy minus y dx. So this is the required result. So hope you have understood this. Now let's move on to next question. So here is the next question. Just we need to define the complementary function and particular integral of differential equation, solve the differential equation, right? So here you see, so complementary function, this is the definition. You will understand better if I solve if I solve a problem, if I solve the problem what is a complementary function. So here you see, this is the equation that we are to solve. So here you can see, and this can be written in this form as well, right? So f of d will be given by this, and auxiliary equation f of m is equal to 0. So this equation can be obtained by just replace the d by m. So here d represents differential coefficient d by dx, right? So hope you know these things. So now you see, this is the auxiliary equation. If you solve this one, you will get here m is equal to -2, and both the roots are -2, so equal and real roots. So for that, the c1 plus x c2 e to the power mx, this is the complementary function of this equation. So now particular integral is given by this. So if the right hand side is x squared, then we can obtain the particular integral by 1 by f of d into x square, right? So I forgot to put the definition of particular integral here, so I will put this one. So wait, so first let me solve this equation, then I will put this definition. I forgot to put the definition here. They have asked the definition of particular integral as well, so I forgot to put that one. So here you see, so how to find a pi is 1 by f of d into x square we have got here. So f of d is this d square plus 4d plus 4, right? So which can be written as d plus 2 whole square, right? This denominator will be d plus 2 whole square, right? If you apply a plus b whole square formula, right? So now let me write this one on the other side. So here you see, I have written the CF again, what we have got. This is the CF we have got. Then pi, so 1 by d square plus 2 d 1 by d plus 2 whole square into x square. So let's take 4 common from here, then what you will get, 1 plus d by 2 whole square. That means what we have done, so d plus 2 whole square, from here you can take 2 common, right, within the bracket. So then it will be 1 plus d by 2 or d by 2 plus 1, same thing, so whole square. On squaring this 2 we have got 4 here. So hope you have understood. These are very simple things. Being the student of BSc physics, you should know these things. Okay, I don't think I need to explain, right? So now you see, this can be written like this. Now you expand this using this formula. So if you expand this, you will get this result. So replace the x by d by 2 here. So if you do so, then you will get this. So we are going to neglect the remaining terms. We are going to take only up to this 3d square by 4, because when you operate x square by d cube, that means if you operate if you differentiate x square 3 times with respect to x, that's going to be 0. That's why we are not going to take the remaining terms. Okay, so where you will get higher power of the more than the power on x. So that's why those gonna be 0 on after differentiation. So that's why they are neglected. So we have taken this part only. If you operate on x square, then you will get this, right? So your solution should be cf plus pi. So we have got this is pi and we have got cf, this one. So if you put this cf and pi, you will get the answer. Again, one more thing is given, that here you can see y of 0 is 0 and y dash of 0 is half, right? So using this information, we can find a value of c1 and c2 here. So y of 0 is equal to 0. If you put this here, y of 0 can be found out from this result. If you put here x is equal to 0, here 0, here 0, and here also 0, then you will get this result. This one, c1 plus 3 by 16, you will get this, right? So which is equal to 0 given in the question, right? So hope you have understood this. Now, okay, now you see, again also given y dash of 0 is equal to half. So let me go to the next slide. So this is the solution I have written here again. Okay, don't write it twice. Just as I have changed the slide, I have written the solution again. So this is the y is equal to 0 and this is the c1, value of c1. This is suppose equation number 1. Now y dash x, so this is yx, so y of x. So if you find y dash of x, you will get this result, and if you put x is equal to 0, then you will get this. So now again y dash of 0 is half given, so put this value here, then what you will get, you will get this relation. And if you put the value of c1 here, then you will get c2, that is equal to 1 by 8. If you put 1 by 8, if you put the value of c2 and c1, that is minus 3 by 16, in this equation y of s is equal to here, if you put here y of x is equal to this, so then you will get the complete solution, right? So that's how we have got this result. Here you can see this is the solution of the given differential equation. This is the required solution. So let's move on to next question. Here you see define line integral and surface integral also. So this is the definition of line integral. Here we have taken this as a vector function and curved AB. The line integral of the vector function f along the curve AB is defined as the integral of the component of f along the tangent to the curve. Okay, and this is given by integration over c of f dot dr. This is the line integral. This is the expression for line integral. And the definition of surface integral is this f be the vector function and s be the given surface. So surface integral of a vector function f over the surface s is defined as the integral of the component of f along the normal to the surface, so which is given by this expression, right? So where n cap is the normal unit vector to the surface element ds, right? So hope you have understood this. Now let's move on to next part of this question. Total work done moving a particle in a force field given by, this is the force, and along x is equal to this, y is equal to this, z is equal to this, from t1 to t2, right? From t1 to t2. So here is the f vector, force f, and we need to find the work done from t1 to t2, right? So let's put the values of t1 x, y, z here, and also if you have x, let's find dx dx by dt. So you have got this dy by dt, dz by dt, right? So why we are doing this, because you know that work done is integration of f dot vector f dot dr vector. So that's why let's find f and dr. So we are to integrate from t1 to t2, as these variables are in x and y, so we have to put those values of x and y in terms of t here. So doing so, we have got vector f is this and dr vector is this. This is the dr vector. So after dr is expressed in terms of t, variable t, and after this f is expressed in terms of variable t, we have got these two, f vector and dr vector, and they are dot product. If you find a dot product, you will get this result. This is the dot product. So work done, to find the work done, we are integrating from t1 to tu. What we are integrating? We are integrating f dot dr, and these are the results. So hope you know integration differentiation better. So now, so finally we have got this 313. This is the work done. This much of work is done. So now let's move on to next question. So I'm going to so maybe I'm going very fast because tomorrow you have exams, so I have to complete this paper today, right? So just pause the video and note these things down. So now let's move on to next. So this is the next question. So that f is equal to this one is conservative force, find the scalar potential, also find the work done moving the object from this point to this point. So here you see I have already done this one in my lecture 11 of vector calculus. Go to playlist, check the playlist with the name vector calculus, see the lecture 11 and skip few minutes, 3 or 4 minutes, because first part of the video is I have explained there I have explained what is line integral, maybe, right? So skip few minutes, then you will get the answer of this question. And either you can go to the description box, click the link given against that I have written question number 4C answer in that way, then the link is attached, right? So you can click that link also, then skip the video few minutes. Okay, now let's go to next question. So here you see what are curvilinear coordinates. I have explained this one in previous paper, so maybe in 2020, that previous paper. So here you see that's why I have not written again, right? So if you have watched all my videos, then you might have got this one. So suppose, so let me define this scalar factor, a scale factor. So suppose r be the position vector in a curvilinear coordinate, okay, u1 u2 u3 of a point p, then these are the scale factor, right? These are the scale factors. So now suppose a vector in curvilinear coordinates, so in curvilinear coordinates u1 u2 u3 b, this is the vectors. So here u1 u2 u3 e3 e1 e2 e3 are the mutually perpendicular base unit vectors, like in rectangular coordinate system, as we used to use that I cap, j cap, k cap, right? And those are replaced by this e1 e2 e3 here. That's the different thing. That's the thing here. So in order to find the divergence of a in curvilinear coordinates, that is del dot a vector, so let's find the del dot a1 e1 first, and if you find that, then you will get this result. So similarly you can find del dot a e2, del dot a e3, and if you put their values, put all these three values here in this equation, then you will get divergence of a, right? You will get divergence of a. This is the divergence of a. So here you can see that in the year 2019, it was asked to find the gradient of a vector in curvilinear coordinate, and this year it was asked to express the divergence of vector. So maybe this semester, that the exam that's going to held tomorrow, tomorrow, maybe asked this time maybe asked that express the curl of a vector in curvilinear coordinates. That's also very important. So read that one also, practice that one also, right? Just I have suggested. Just now you can see the next part of this question. hence write the expression in spherical polar coordinates also. So let me write this this expression in spherical polar coordinate also. So divergence expression in spherical polar coordinates. So divergence in spherical polar coordinates. So here you see. So this is the first slide. Just note it. Just pause the video and note it. I'm not gonna explain today because you have not enough time. Just don't waste time. Okay. So tomorrow you have exam. So here is the next slide. Okay, and this is the third slide. Just pause it and note it, right? So here you will get you have got here a grade of f and Laplace operator on f. So these are not required if divergence is asked. Okay, so if you need to find the grade in spherical polar coordinates, then you can write this one. So now, so this is divergence, this is curl. Okay, so we need only this in this question. For this question you need this only, right? So this is the last slide of this answer. So hope you have understood. So paper is completed. Just I forgot to put the definition of particular integral. Let me put that one. Just wait. So here it was asked a particular integral. I forgot to write the particular integral. So let me clean this part. I will write here now. So that's, so here you see when suppose when y is equal to f of x, this is a function of x, plus c z of x is a solution of n ordinary differential equation. Just write the full form, ordinary differential equation. Then here f is called the particular integral. This function f is called the particular integral. Right, which can be found in this way. So different expressions, for different expressions there is a different method. So now you see and this here z will be called as the complementary function. Okay, just I have already defined this one. Just I forgot to this define this particular integral. Just so you can write this way. So hope you have understood this. So wish you all the best for the upcoming your first semester exam, final exam. So thank you for watching and stay connected, and don't forget to choose the course that I have posted in community post. Please go there and subscribe the channel and share the videos, hit the thumbs up button, hit the bell icon so that you get notified when new video will be uploaded. So thank you for watching. See you in the next video very soon.